Before we start, I just want to make a note about this Max Console window. This is a useful window to have open because it's going to show you errors that pop up in your patch. So if you've typed in something wrong or made a connection that doesn't make sense, Max Console will try to report those errors to you in a way that'll help you debug your patch. And if this window ever gets closed, the Max Console, you can always go to the Window menu and bring the Max Console back up, or Command-Shift-M will also bring that window back up. So let's make a new project. Please put your name in your project name and be descriptive. Let's, in our project, create a new file. So we click on the plus and say Add New File. And we want to create a new file inside our project folder. So you see this is my project folder. There's my MaxProj file. And I'll call this Tutorial 2. And here's my Max Patcher. And just to take a look at our project file one more time, here's our John J Tutorial 2 project folder. Here's our John J Tutorial 2.maxproj file, which refers to this window. And then it's created a new subfolder called Patchers, and inside it's put the Tutorial 2.maxpat. You don't want to manually mess around with what's inside this folder, but you want to be aware that there's a folder full of files that's being manipulated by the Max project. That's really what the project is a control interface for a folder full of related files on your computer. And we'll look more at that later. We'll start with a jit.world. And this time we're going to give our world a name. So we're going to type an argument into the jit.world object that specifies the name of the world we're creating. And this will become important later. And one of the conventions we're going to use for this class is anytime we name anything ourselves, anytime we give something an arbitrary name, we're going to put it in all capital letters. So since this is Tutorial 2, I'll just call our world T2, and I'll make that a capital T to show that that is something that we created. And you'll see when it creates the jit.world that now the window is labeled T2. And notice we're not in our monospace font here. You always want to make sure that you switch into that monospace font, such as Monaco, Courier, and Del Mono. Those are all very good ones. And I like to up the font size a little bit too for readability. I like to stack my windows so that things are in readable rows. So here's my world. In the first tutorial, we looked at the enable one attribute to turn a world on. Here's another method. We're going to create a toggle, which is essentially an on-off switch in our patch. So press the letter T, that'll create the toggle, and then we connect the toggle to the jit.world. And when we command click the toggle or lock the patch and click the toggle, that sends the message 1 to the jit.world, which turns the world on. And these are equivalent things, and we're going to be looking at the fact that there's always more than one way to do things in Macs. So jit.world T2 at enable 1 is the same as connecting a toggle to the world and turning the toggle on. And in fact, you can use them in combination. You can use at enable 1 and you can connect the toggle to your world, and they'll both function. jit.gl.handle so that I can change my view on the world with a message of reset so that I can reset my view. So we're going to place objects into our world just like last time, but with each tutorial we're going to learn a little bit more about objects, add more features to them, more complexity and possibilities. One thing I want to make sure is that my handle is also placed into my world, T2. So it's a jit.gl.handle space T2, just so if you have multiple patches open, the handle doesn't get confused about which world it's referring to. So I option click and drag, and that zooms out, and there's my cube. Obviously lighting is not enabled, so I can do that at lighting enable 1, turns on lighting, and now it looks a bit more like a three-dimensional object. I can give it some color. 011 will give me a teal colored cube. The element that we're going to add is now we're going to make this a physics object. In other words, we're going to make it an object with mass that interacts with other objects as if it were a real solid object. And to do that, we need to add a jit.phys.body. And it also needs to have a matching shape cube. And right now, we're going to say this is a body that gravity and forces do not affect. So we're going to make it kinematic, K-I-N-E-M-A-T-I-C, kinematic 1. So this is a static mesh, as what it would be called in other environments. And give it a certain scale, and give it a certain position. Now, last time, scale and position were attributes of the grid shape itself. But when we're turning the grid shape into a physics body, we are going to specify the scale and the position in the jit.phys.body. So here's one object, and I'm going to create a second object, which is a sphere. And I also need its physics body to be a sphere. I'll give it a different color, and I'll position it slightly differently as well so we can see it. There it is, poking out the side there. I'll make my cube a bit smaller. There, so there's my cube and my sphere. And they're both kinematic objects, so they're both not affected by gravity or other forces. If they were affected by gravity, I can turn off kinematic, turn on kinematic 0 here, and we'll see that gravity affects it and it falls down. I don't want that to happen, so it's going to be kinematic 1 for the moment. And as we start to place these objects into a real physical space, it's helpful for us to have a floor. Right now our objects are kind of floating in space. There's no up or down. So I'm going to create a floor underneath my objects with another kinematic physics body. It's going to be a cube, but I'm going to give it a scale of 5 meters wide, 0.1 meters high, and 5 meters deep, and I'm going to position it at 1 meter below center. Right, so at scale 5.15 means 5 meters wide, 1 meter thick, and 5 meters deep, and centered left and right, 1 meter below center, and centered in depth. And we can see here it's created this floor, and we'll color that differently. I'll just make it white for the moment. And because of the lighting, it's showing up as gray, but it's actually a white object. And we can see that my sphere and my cube are not quite sitting on this floor. If I were to now turn off kinematic on the cube, we'll see that it falls down and it lays on the floor, but also it'll no longer overlap with the sphere. Same thing with our sphere. If we turn off kinematic, the sphere will sit on top of the floor we've created. And if we create another object, it will physically interact with these other two objects. So let me just duplicate the cube here. You see it creates another cube and it pushes the other two cubes away. Or if I want to, I can add a Y position here to this cube so that it falls. And then if I cut these and paste them all back in, I'm having these objects that are in a physical simulation. This cube is sitting on top of this cube. When this cube fell, it pushed the ball away, and the ball rolled to the right, and they're all resting on the floor. I'm going to go back to a kinematic arrangement. And the nice thing about the kinematic arrangement is it allows the cube and the sphere to overlap each other. But notice the top cube, let me color this one differently. I'll color it green, is now resting on top of these. But because they're kinematic, they're not pushed out of the way by the force of the cube resting on top of them. So experiment with this a little bit. Make sure that you're fully understanding what's happening here. And also notice how cube fell off. Notice how I'm placing the fizz body to the right of the grid shape. You probably just want to do that as a standard. And then you probably want to label things as well with the C for comment. Call this the floor. Call this the blue cube. Call this the red sphere. And we'll call this the green cube. So right now there is obviously a camera. There's a camera that's showing us this image. There's a virtual camera in the scene. But when we hit reset, our camera's too close. So we can actually use the jit.gl.camera object to just set a default location for our camera so that when we hit reset, we're not zoomed so close into the object. The default location for the camera is position 002. We can give it, let's try 014, which is 1 meter above center and 4 meters back. And we can see that we get a better view of things. We can go even further back, 6 meters back. And that way, when we reset our handle, this is the view we get instead of getting that view that's right up against the cube. But if you notice, this camera is kind of looking over the top of our objects. I'll give you a new attribute, the look at. Because a camera can not only have a position, it can have something that it's looking at. So we can look at the center and we see the camera tilts down. So now we still have our jit.gl.handle. I'm going to place this camera into the world. Place the camera in the world T2. We still have our jit.gl.handle, but when we reset it, it resets back to this camera position. So we manipulate things, we move things around, look at our scene the way we want to, and then when we hit reset, it goes back to the camera position we've specified in our jit.gl.camera T2. We're going to cover much more about the camera later on. This is just a starting place. So the next element I want to look at today is materiality. These objects, they're cool looking, but they don't have a lot of character to them. They're just plain, simple colored shapes. And that's nice, and if that's a look that you're going for, it's totally acceptable, but there's a lot more that we can do in terms of texturing of objects. And we do that by adding the jit.gl.material object. And as soon as we apply material, let's apply it to the floor first, it gives us a much finer shading, and it allows us to do lighting. So let's put a jit.gl.material on each of our objects, and you'll immediately see they begin reacting differently visually. And once our objects have materials, we can start lighting our scene, and this gives us a great deal more versatility in how things look, because right now we're relying on a default lighting, but as you know, if you've done single camera or multi-camera production, lighting your scene is very important for creating the mood and feeling of the scene. So let's add a jit.gl.light. We'll put it at position 1 meter to the right, 2 meters above the center. We're going to make it a type spot. It's a spotlight. And we can see now we're all immediately have a much more dramatic scene happening. Just like the camera, our spotlight can have an at look at. In other words, what's our spotlight pointed at? We'll point it at the center of the scene. So now our spotlight is pointed at position 0, 0, 0. The spotlight is by default a very hard-edged spotlight, so we give it an at spot fall off of kind of an arbitrary value here, just set it so it looks good to you, but a spot fall off of 10 gives us a nice soft spotlight. So as you remember from Sight, Sound, Motion, the aesthetics class, typically we light with more than one light. Usually we'll light with 3 lights, so we'll create another light here that's located to the left. And now we can see we have 2 lights lighting our scene. And a third light often will be from the back. Two meters behind our scene. And now we have 3 angles of light hitting our object. You can see it's lit from several directions. Not very much from the front, so we can actually change our Z here and put these lights a bit in the front, so we have some light hitting from the front. So here we have it. I can rearrange these so they make a bit more sense. And we can change the color of these lights, not with the color attribute, but actually with the diffuse attribute. So I can make this for instance, a yellow light. And now we can see that one of my lights is yellow. Or a red light, that looks nice. So that's the basics of lighting, and I'll show you, one of the things we can't do right now is we can't turn our lights on and off. So if you have something that can be turned on and off with a 1 and a 0, there's a very simple formula in Max. It's T for the toggle, and then a message that has the attribute you want to turn on and off. So in this case, if we want to turn a light on and off, it's the enable attribute. We say enable space $1. And then if we connect the toggle through to our object, this enables us to turn on and off that light. It's either enabled or disabled, so we can see the effect that each light is having on our scene. So we'll attach that to each of the lights in turn. Enable $1, enable $1, and enable $1. So now we can see the effects of each individual light. We can turn them all off, and our scene is lit by the default light. If I turn on just the back light, we see we have light coming only from the back. If I turn on just the red light, we see the scene is illuminated only in red, so the the green object is not really visible, which is the same that would happen in the real world. If you illuminated a green object in a red light, it would not be visible. And here's our white light. Here's just the white and red lights, just the white and backlights, just the red and backlight. And so you can see how the different combinations of light affect the images. And it's nice to look at these from different angles as well, so you can really get a sense of how the light is changing the scene. So as one final addition to this section, we're going to look at putting a texture, a simple texture, into our jit.gl.material. So we do that by taking any image file. Here I have a folder full of photos of textures. When I'm traveling, I enjoy shooting photographs of the textures of things that I find, because I find they're often quite interesting. So this is just some light falling through a fence onto sand, and I liked the texture that it created, so I took a photograph of that. And any photograph like that I can take, and I can, if I want to use it, I'll drag it first into my project. And now here's the power of the project, is that the project is going to store this image file, so that even if I move my project to another computer, when you upload it to Blackboard, the file will remain in your project. So I drag it into my project, and here I have a couple images I know I want to use. So I'll drag them all into my project. Once they're in your project, they haven't actually been copied to your project folder yet. If I take a look in my project folder here, there's no images in my project folder. But if I go here to the Manage Project icon here and I say Consolidate, this will actually copy those image files into a media folder in my project. Now you want to be a little careful about your file sizes here, because these are image files, so 4.4 megabytes, 3.2 megabytes, 2.3 megabytes. That's not that big, but already my project folder is getting to be around 10 megabytes in size. So project folders will quickly expand once you start adding audio, and even if you add video files to them, they'll get very large. So just be thoughtful about the file size of the files that you're putting into your project. If they're relatively small files like this, that's not going to cause a problem. But if you put like a 500 megabyte file into your project, then your project's going to be very heavy and hard to share. So what are we going to do with these images? Well, the jit.gl.material object has a lot of inlets across the top, and these are for putting textures into. We're just going to use the leftmost, the first inlet for now, which is called the diffuse texture. So I'll take one of these textures, drag it into my patch, and we see there's the image. And then I can connect the outlet of the image to the left inlet of jit.gl.material. I'll just shrink this down because I don't need the icon to be large. And then I need a button, which I'll attach to the image. And when I click the button, it sends that texture to the jit.gl.material and textures my object. So now I have a much more interesting looking cube because it's got this texture written across it. And you can do this easily with any of your objects. So I'll take another, and I can use this texture for my red sphere. I can use the same button or a different button, doesn't matter. And now my sphere is textured as well. And the color of the sphere is overriding the nice color of the texture. It doesn't have to. I can just take the color and set the color of the sphere to white, which will allow the entire coloration of the texture to take over the sphere. I could do this with my blue cube as well. It doesn't need to be blue. These are still a bit reddish because one of my lights is red, but you can see we're starting to get much more interesting looking objects. And I can take a third texture, drag the texture in, and I can texture my floor with this one. Again, using the same button if I want to. There, and now my floor is textured. So you can see you've got a much different and more interesting visual situation. And remember, we're in a physics simulation now, so every time I close and reopen this patch, this cube that's sitting here off to the side is actually going to appear up here, and gravity will pull it down and it will fall over these other two. So let's take a look at that. Turn my world on and watch what happens inside of my world. That green sphere falls, and oh, it doesn't quite slide off, but it will probably slide off in a minute. And notice my textures don't send. I need to manually send my textures, and then my textures will come in. If I want the textures to send automatically, I can just connect my toggle that's turning on my world to the button that sends the textures, so that as soon as I turn on my world, it will also send the textures. Let's try that. We'll close this again, open it back up, and watch. As soon as I turn on my world, it will also press the button to send the textures. And there we go. One thing you're going to want to do, I've made this a little bit large so that it's easy to watch in the tutorial, but when you make this, you're going to want to put a little bit of effort into laying things out so they make a certain kind of visual sense on your screen. Perhaps something like this. Move these over here and put my camera there under my world. Oop, there. The green cube just fell off the top. We could, later we're going to learn, we could, for instance, increase the friction so the cube doesn't slide off the top, or decrease the friction on the interaction of the bodies so the cube slides off more rapidly from the top. But these are simulated real physical objects interacting in our world. And so what I'm doing here is I'm just organizing things a bit. One more thing you might want to do here is see how these enables are all showing as off, but they're actually on because the default value is on. So we need to turn them on before we turn them off. So you could just, again, connect this toggle that starts your world to also set the toggles of your lighting enable, just so they're in the correct state. Save the patch, close it, reopen it. And now this toggle turns on our lighting enable toggles, sends the textures, and turns on the world so that everything is in exactly the state that we want it at the beginning. So first of all, some of our descriptions in the comments are no longer accurate. You're going to want to update that anytime you're working so that your comments match what's actually going on. And you'll notice one conspicuous omission here from our lighting scenario. These objects don't cast shadows. So that is actually an attribute of lights. We can say shadows $1, and that will turn on and off shadows. I'm going to add another attribute here because shadows, computing shadows, can be very costly for the computer. So we are going to use shadow quality low. And in this case, low is spelled L-O. So shadows $1, shadow quality low. And because shadows is a Boolean attribute, it's either 1 or 0, we can use our trick of connecting a toggle to a message box where it's shadows space $1, and that will allow us to turn on and off shadows for the 3 lights. So now we can see shadows are on, and we get a much more realistic rendering of the scene because our lights are casting shadows. And if we drop our green cube, we can say position 0, 5, 0, mean we're going to make this cube jump to 5 meters above the center point of our world. It falls and we can see its shadow is rendered as well. And then this gives us a handy button to cause our cube to jump down anytime we want. And we can combine this with a scale message to make the cube smaller. So you can see that with the addition of the shadows, our scene becomes quite dark and it's a bit hard to see things. It's nice, it's very dramatic, and you might want this for a project, but for a tutorial, it's a bit dim. So let's add an additional light, jit.gl.light, and these lights should be placed into the world, T2, and we should go back and put T2s into these as well. Just in case we have multiple worlds open, we don't want the software to be confused as to which world the light belongs in. I'm going to position this light directly overhead, maybe 6 meters over the center, and I'm going to use a different light type. I'm going to use type point, and a point light is like a light bulb or the sun. So my jit.gl.light in world T2 at position 6 meters above the center of the world, type point, and then to specify the color of a light, we use diffuse, and we'll make it quite a dim light, say 0.125. Just a little bit of extra lighting to make the scene a bit brighter. And notice that I'm not going to turn on shadows for this light. Why? Because this is a direct top light, so the shadows are going to be mostly right underneath the objects. And remember that computing shadows is computationally expensive, so we don't want to compute any shadows we don't absolutely need to. Now, obviously what's happening here is our screen is getting really unmanageably cluttered, so it's time to go and do some encapsulation. I'm going to select my sculpture here, say Edit, Encapsulate, and call it Sculpture, and we can see that the objects are reinstantiated when we encapsulate them, so I need to send the textures back to the objects, and any messages that you use to configure your objects will need to be sent again. We can see in the subpatch that the inlet is simply sending the textures into the jit.gl.material. Nice thing about subpatchers is we can rearrange things for readability, and you need to do that in your tutorials and in your own work. Rearrange for readability, particularly now in the beginning stages while you're just learning, to make your patches as legible as possible. Another thing we can encapsulate is the lighting, but when you encapsulate lighting, you have to be very careful because it will not necessarily recompute properly until you open and close your patch, so you might get some unexpected results. So when I rebuild lighting, I'll actually turn off my world, stop it from rendering, and do a little bit of management before I encapsulate. So the first thing I want to do here is, if I'm going to encapsulate like so, Edit, Encapsulate, I'm going to have these toggle boxes outside my patcher, and I might forget what they're for. So before I encapsulate, go to Edit, De-encapsulate, I'm going to label these toggles. Call this one Shadows. Call this one Key Light. Call this one Fill Light. Make a note that that's the red light, and call this one Backlight. And I can certainly add and enable to the new light that I just made. Call this Work Light. So I'll take all my lighting stuff, edit, encapsulate it, call my encapsulation lighting, and build my little lighting control panel. I have my shadows, I have my key light, fill light, backlight, and my work light. And Command Y will tidy things up into a nice row. And now I want to save this, close the patch, reopen it, because otherwise my lighting may not render correctly. And also I do want this work light connected to my main toggle. I can also make my shadows connected to my main toggle. In fact, just to remove all of these extra lines, I'll just make an extra toggle here and connect it to all of my lighting related toggles. That means instead of having 5 patch cords coming down the screen, I have 1 patch cord coming down the screen and then 5, that cube fell over again, that's funny, 5 shorter patch cords related to my lighting. Another thing you are going to find useful, I'll show it to you now, is if you option click and drag over any patch cords or objects that you want to hide, you can say under Object, Hide on Lock, so that when you lock, those disappear. And you can do this with any patch cords that you want to hide. So I can option click and drag over these patch cords and Object Hide on Lock or Command K. And then when you lock your patch, see now I've got a nice lighting control panel here without the clutter of patch cords. Is there anything else I can encapsulate in this moment? Sure, I can encapsulate both of these, in fact. I'm going to leave the floor out for a moment, but I will encapsulate my green cube. Edit, encapsulate, green cube, Command J to fix with, and I've left my message, my control outside, so you can see how much screen landscape I've recovered here. So the next thing we're going to look at is we're going to look at just one of the properties of physics objects, which is their bounciness, because this gives you a lot of flexibility in terms of how objects interact with each other. So I'm going to first make a copy of my green cube, and I'm going to call it red sphere. And these, of course, are in all caps, meaning I can change them to whatever I want. And I'm going to go into my red sphere and make it be a red sphere. So change my shape to sphere, change my physics body shape to sphere. I'm going to change the scale to 0.25, make it red, and there's my little red sphere there. And I'm going to add a new attribute. And as always, I'm going to change into Monaco 14 point just for readability. I'm going to add a new attribute, which is restitution. And restitution is essentially bounciness. It's how much energy of an impact is transmitted back into the object in an opposite direction, how much rebound the object has. So I could say a restitution of 0.5, meaning 50% of the energy of the object is going to be transmitted back into the object upon impact. Now you notice that when I did that, it actually didn't bounce at all, because also the objects it's hitting need to have restitution as well. Let me move this over so it's only hitting the floor 1 meter to the left of center, 5 meters above, and 2 meters towards me. And it has restitution, but the floor doesn't. So I need to go up here to my floor and give my floor a certain amount of restitution as well. I'll make my floor like 0.75 restitution. So my sphere has a restitution of 0.5, my floor has a restitution of 0.75, and that's going to be quite bouncy, as you can see. If I want things to be bouncier, I can make either the floor bouncier, for instance, give the floor a restitution of 1, and that's going to make the bounce be higher. If everything has a restitution of 1, the bounce will put all of the energy back in. It's an extremely, extremely bouncy surface. So you want to be careful with restitution of 1. A restitution greater than 1 is going to make for accelerating rebounds, which can be interesting, but also can get quite chaotic. So let's turn our restitution back to 0.75. 0.75. But we notice here that if we drop our ball onto our sculpture, so if we drop it from 5 meters above the center position, it doesn't bounce. Why? Because our sculpture has no restitution. So we'll go into our sculpture and, again, as always, Monaco is going to make things readable. We'll do a restitution of 0.5 on the sculpture. That will make the sculpture itself somewhat bouncy. And I'm always careful about making my ats line up for the sake of readability. As your patches get more and more complex, this will become increasingly important. I drop the sphere onto the sculpture, and we see the sculpture itself is now bouncy.